In today's experience, I wanted to cover a problem from mathleague.org. Mathleague.org is this wonderful organization that sponsors contests for elementary, middle school, and high school across the United States and in a couple of other countries. And what I love about their problem is that they use integrated math. And what that means is that their problems will cover many strands of mathematics. They can reach back across your entire mathematics education and then some. They can even look ahead into things you'll be learning down the road and expect you to take what you know and figure it out. So these are wonderful problems. They're for sale. If you go to the mathleague.org website, you can actually purchase these contest sets and give them a try for yourself. So let's jump in. The problem I wanted to try today, it is from, let's see, mathleague.org. The problem is from contest set number 11827, and this is the team round. And the problem I wanted to try was number 10. Let's read it. A right circular cylinder has a diameter of 8 inches and a height of 12 inches. It's completely filled with water, and all of the water is then poured into a right circular cylinder with a diameter of 12 inches. How deep is the water in the second cylinder in inches? Express your answer as a decimal to the nearest hundredth. Okay, so the first step with Polya's problem-solving process is always to make sure that we have a good mental picture of the problem, that we can actually restate it in our own words. If I was going to restate this problem, I have a cylinder. I know I said a right circular cylinder. I'm just going to say I have a cylinder. It's got a diameter of 8 inches, a height of 12 inches. I have a second cylinder with a diameter of 12 inches, and I don't know the height. The first cylinder is filled with water. I'm going to pour it into the second cylinder and see what the height of the water will be. And my answer has to be in inches and has to be to the 100th degree. So let's jump in and bring this into our problem-solving structure and give this a try. So rather than write this out, what I like to do for this problem, especially since I haven't worked on these type of problems in a while, is I want to have a visual representation of what this problem means. So let's see, I'm going to start off and we'll draw that cylinder. Okay. There we go. Let's use the thicker thing. Okay, so the first thing I'm going to do is I'm going to draw a cylinder. There we go, and I can use Notability's feature and copy and paste that. And then I'll draw, let's see, 2 lines. Okay, so there's my first cylinder. And what I can do is then copy and change this up a little bit, maybe that side, copy and paste to get my second cylinder. Now the second cylinder has a wider diameter, so let's make that bigger. Oh, that's right. The problem with Notability is you can resize images, but it's always proportional unless if it's a rectangle or an ellipse, but that's okay. I think for the purpose of our problem, we get the idea that the right cylinder is bigger than the left cylinder, the first cylinder. Now the first cylinder is filled with water, so let's fill her up with water. Okay, now what we're going to do is then in the problem it said to take that first cylinder and pour all of that water into the second cylinder. Let's do that. Shrink down the water a little bit. It's all going to pour into there, and remember, conservation of matter. If we have the volume of that water in that first cylinder and we pour it into the second, the volume is going to stay the same. So remember about conservation of matter. That's really important, in my mind at least, for this problem. So it's going to fill up. It's going to fill up to some height, which we don't know. But what we do know, what we were given is we're given the diameter of this first cylinder, and that was 8 inches. And we were given the height of this first cylinder, and that was 12 inches. And for the second cylinder, all we were given was the diameter of 12 inches. Okay, I think that's a great picture of what we're trying to do, and I think I have a better understanding now that I've drawn this out and started to think about it. I'm going to move this over here. And so what's, the first thing I think we should do is answer, what do we notice? Looking at this picture, what do we notice? Maybe pause the video even for a second and just jot down some things that you might notice about this problem so far, especially after we've drawn it out. What I notice is that, just thinking logically using common sense, the water, the first cylinder, right, it's filled with water. If I'm pouring that into a second cylinder and that second cylinder is bigger, well, I would guess that it has to be a height that's smaller than that 12 inches. So the first thing I'm noticing is that the height must be less than 12 inches. And let's see. The second thing I noticed is, I'm wondering, is there some type of proportional relationship between the first cylinder and the second? We see that the height is 12 inches, the diameter is 8 inches, but on the second one, the diameter is 12 inches. Does that mean the height is going to be 8 inches? I would say it's kind of like a guess that I would make. I don't know. I mean, I'd have to examine that and prove it out, but even if I wanted to make an educated guess right now, for something to be directly proportional, it's usually multiplication formulas that are equal to each other. And this is a volume problem, and what we're looking at is the volume of the first cylinder is going to be equal to the volume of the second cylinder. And so volume is typically base times height, or I should say always base times height. And yeah, I mean, there could be some type of proportional relationship between the two. Anything else I want to think about or understand before I move on? I mean, at this point, I can see that the skill I'm going to be using here is geometry. If I go back to my little magic cube, let's see if I can easily get there from my list. I can just go back to the heuristics list. And remember, if we think about all the things that we've learned, we're definitely looking around that area of geometry where, we're looking at a cylinder is a polyhedron, and we're looking at the volume of a cylinder. So I think that that's the skill set that I'm definitely going to need to know. I'm going to need to know those formulas for volume, specifically for cylinder. So I think I've got a great understanding of this problem. I think it's time to start to plan an approach. So when I'm going to plan an approach, you've heard me say this before, I'm always going to look at my heuristics list. And in this case, for my problem solving, it's, I have to say, it's really not a heuristics list because, here it's really just a list of methods that I could take for solving problems. If it was going to be heuristics, I really need to have those criterion constraints that help me decide when do I want to make a list or a table, when do I want to solve a smaller version of the same problem. But for what I'm doing right now, I'm going to use this list and just see. Now, I really don't have the ability right now to act out this problem. I decided to represent it visually in a picture. That was helpful. Now, I could be making a number line, making a list, limiting possibilities, solving a smaller version. Nothing's clicking yet, but examine a guess, that is clicking, and that is something that I think I want to try because I have this guess, and why don't I examine it and see if where that takes me, if that actually gets me to the answer. Now again, I can't just say, the answer is 8 inches, but that's my guess right now, is that height, I'm just going to write that the height, so I remember, is 8 inches. So but I have to really give it a good exam and a good thing. So let's see. I'm going to write for my plan of attack is going to be examine a guess. And let's see. Let's think about what that means before we jump into trying it out. And we know that we've already said that the volume is equal to the volume of 1 is equal to 2. We know that the base times height is equal to the base times height. So that's really where I'm going to be working from, is to examine my guess. I want to be, let's see, I'm going to write this out in blue. I got it in a nice, all right. So I'm going to be examining this formula and seeing if the base 1 times height 1 is equal to the base 2 of height 2, such that the height is equal to 8 inches. The height of the second one is equal to 8 inches. And I'm already given all the other information. So let's give that a shot. I think, there's a possibility this can work. And let's give this a try. So, all right, I have base 1 is height 1 is equal to base 2, height 2, and now we need to know what the formula for base is equal to. The base is, in this case, the base is going to be this circle. I know it looks a little bit like an ellipse with the way that I drew it, but that's a circle. And we want the area of that for the base, and that is going to be, base is equal to pi r squared, because that is the formula for area of a circle. So there's my formula. I'm going to substitute that in for b on each side. So I'm going to have pi r1 squared h1 is equal to pi r2 squared for h2. And I can cancel out those pi's, and I end up with r1 squared h1 is equal to r2 squared h2. And that's my formula. So now what I would do is substitute in the values for the variables. The radius for the first cylinder was 8 inches. Actually, the diameter was 8 inches. So the radius is going to be 8 divided by 2, which is 4. So let's put that in here, 4 squared. The height was 12 inches. See, it really does help that I've got a good mental picture of this problem. I can just put in my numbers. Now the second cylinder, I remember it was the same as the height of the first one. So it was 12. 12 divided by 2 is the radius, which would be 6. And the height I was estimating was going to be 8. Okay, now let's simplify this problem by removing common factors from each side. So I have a factor of 4 that can get removed over here and here. That would become 2. I have a factor of 6 that can be removed here and here. That would become 2. I can quickly see that this is not going to work. 4 times 2 is 8 on one side. I've got 6 times 2 is 12. 8 does not equal to 12. So my exam, and I guess, resulted in false. I need to quickly move on to a different approach. And I think I saw it as I was typing. As I was writing this out, I saw that the formula itself, I could just use that formula. Instead of trying to substitute in the value of 8, why don't I just solve for the unknown? So my second is going to be use a formula and solve for the unknown. Let's give that a shot. I think this is definitely going to work because I have most of the work already done. So if we go back to the problem that I tried before, and if we look at, let's see, the formula that we wanted to use is right here. We're just going to reuse this formula, but let's shrink up the work that we've done. We don't want to get rid of it because maybe there's something that we can reuse there. For example, we can reuse the formula, and let's use, maybe we can even use a different, no, I don't like a whole bunch of different colors. That doesn't work for me. Okay, so my second try is going to be R1 is still equal to 4, and I'm still going to square it. H1 is still equal to 12, and R2 squared, that's still 6 squared. And h2, now I'm going to leave h2 as the unknown variable that we're going to solve for. And I can still simplify out where I have common factors. So I have a common factor of 6 on each side of this equation. So I can remove that common factor and remove that, and I would get a 2. And even the 2 can go into that 6. Let's remove the common factor of 2 out, and the 6 becomes a 3. All right, so we have 4 squared is equal to 16 is equal to 3 times h2. And we're going to divide each side by 3. And so we would get for h2 is equal to 3 goes into 16 5 times, and that's 5 1/3. And we know 1/3 is 3, 3, 3, 3, 3. It doesn't terminate, but the problem had told us we only need to go to the 100th. So I'm going to write 5.33, and I'm going to add my units of measure, which was inches. Since we're dealing with height, that's definitely inches. And I think I'm feeling really good about this answer. I'm going to put a box around it, and that's great. So I want to make sure I answer the ask, and they had asked us for the height, and it asked us for an answer in inches and decimal to the 100th. So I'm feeling really good about that. Now, let's look back though at this answer and just do our normal checklist. I love to use this checklist because it keeps me honest. Did I answer the ask? Yes, we already checked that out during the triad phase. Does my answer hold water? Did I get the number and type of values that I predicted? Well, I knew that I wanted to get a height. And the one thing I did know about the height is that I wanted it to be less than 12, because just through common sense, it couldn't have been greater than 12. And that's making me feel really good about my answer, because if my answer was 20 or something, I know I'd have a problem. But the fact that it's 5.33 inches, and that's almost in that same ballpark as my guess, I'm feeling really good about my answer in terms of what I was expecting. So let's see. I got the answer I predicted. I don't have any extraneous values. How can I best check the answer? Well, I could check it by substituting the numbers back into the original equation. I'm not going to do that for the sake of time here, but that would be definitely a good check just to make sure I don't have any mathematical errors in my answer. And so that gets that. So I answered the ask. My answer holds water. Let's think about what worked, what didn't work in our path. So I definitely, when I think about what I did here, I would have to say what didn't work is that I chased a red herring. And let's think about this red herring. In my own defense, I'd have to say, did mathleague.org kind of set me up for this? Because, they gave me that 12 inches and the 8 inches diameter, and then they gave me the diameter 12 inches. I have a feeling that was a red herring that was kind of planted by mathleague.org to get me going down that path and see if I was smart enough to notice what the issue with that rationale would be. And the issue with that rationale is it comes back to this, the fact that even though if we look at base times height, it does look like it's got a direct proportional relationship because it's multiplication on each side. But once you fill out the formula for the base, you start to realize that, this is an exponential relationship, and that's not going to be directly proportional, and that's why that didn't work. So I understand why my red herring did not work. And, it's because it wasn't it wasn't proportional. Because there's an exponent. So at least I understand where I went wrong. And the thing that I do like about what I did is that, let's paste this over. Oh, interesting. Let's just start with another text. There we go. The thing that I did like about what I did as a problem solver, I spotted the red herring, rejected it, and quickly moved on. And that I consider a great success as a problem solver, because that's really what we want to be doing. Is we know that we're going to go down a couple of paths as we explore what the answer can possibly be, but we need to be monitoring and managing our resources, our time, our accuracy, and our efficiency. And I think I did a great job at doing that for this problem. Now, how does my plan compare? Well, the great thing is mathlink.org provides me with the answers, and they give me an idea of how they would solve it. So let's take a look at what they did to come up with this answer. Let's see. So their answer is, let's see, right here. The radius of the first cylinder is 4 inches, and its volume is 4 squared times 12 times pi is equal to 192 pi cubic inches. The second cylinder has a radius of 6 inches and a base area of 6 squared times pi is equal to 36 square inches. Therefore, the height of the water is the second cylinder is 192 pi over 36 pi, which equals 5.33 inches. So the great news is I got the answer. And when I compare what I did versus what they did, the first thing I notice is they didn't need to go through the visual representation. They didn't even fully fill out the formulas. You know, they kind of jumped straight to coming up with what's the volume and then comparing that to or dividing that by what the base is to get the height. And I think that for a beginner problem solver, I like my approach because it helped me think out and plan and get to the answer. But as an expert problem solver, I definitely want to be using mathlink.org's approach because it's going to get me the answer in probably about 2 to 3 minutes. And so I want to go back to my problem and just make sure that I have a game plan moving forward. And I think what I would like to do is I like to retry this problem, not today, maybe not tomorrow, but in a couple of days within this week. And what I want to do is see if I can I solve it in, I'd say, 2 to 3 minutes. And the reason I think I can do this is, again, I have that mental picture now. I don't need to be drawing out the visual representation. I can get straight to the formulas and fill in only the part of the formula that I need at the highest level, and that would work out much better. The other thing, I mean, if this is what I would need to do, this is where I need to improve. You need to be thinking about what you need to do to improve moving forward. Perhaps when you saw this problem, you couldn't remember the formula for the volume of a cylinder, and it would be a great opportunity on your list. You might write something like review volume, and this would be under geometry. And, you know, there's so many places these days. I still love Khan Academy. So you might go out to Khan Academy and do a quick review. Or maybe you have a textbook that you can quickly review, or your notes, and make sure that that volume, it should be right at your fingertips. You know, everything in math that we learn, we grow and we build upon. We shouldn't be losing. We should be able to quickly retrieve the skill sets that we learn. And that's all I have to cover for today's problem. Please feel free to add any comments or reach out with any questions, and I look forward to working with you on the next math experience. And have a great math